Good morning, everybody, and welcome to OWASP AppSecEU virtual in the year of 2022. Today, we are going to talk about Web Honeypot projects with respect to OWASP. Of course, this is really important to understand on how we can get protected without any kind of information on the attack that attackers can do on us, right? So it is really important for us to gather some kind of intelligence to prepare ourselves better on the approach that attackers can take. And today we have Adrian Winckles, who is going to take us through the journey on how we can actually understand about the path that attackers take to do attacks on different applications. And we'll explain also about the project that OWASP has taken with respect to the Honeypot. Adrian is a director of cybersecurity and networking research group in Anglia Ruskin University and has been associated with OWASP for quite some time. And I would like Adrian to welcome, and I'll give him the stage to introduce himself and also talk about Honeypot Threat Intelligence project. Welcome, Adrian.
Okay, thank you very much. Thank you, and good morning, everyone in UK time, or good afternoon if you're elsewhere. To introduce myself, my name's Adrian Winckles. I have been associated with OWASP, both as a chapter leader for OWASP Cambridge and the OWASP Europe board member since 2012, so about 10 years. And I'm also involved with a number of other professional bodies, SciSec and the BTS's Cyber Forensics Special Interest Group. And my main role is one of security research at an academic institution in Cambridge in the UK. So, for more purposes, why honeypots, or why OWASP honeypots? The majority of web-related traffic is HTTP and HTTPS. In our modern age of cloud, if you like, many of our SaaS offerings are, of course, web applications. So, in a way, we need to be very mindful of what web traffic is coming in and out of an organization, how it can be abused, and that not all traffic is genuine. We also need to understand, of course, that we need to understand where the threats come from, where who could be an imposter, all those sort of arguments. So we need to understand, in the age of encryption, what's going on inside those packets, but we need to know if they're coming from a unusual source. Is it something that's been associated with previous attacks or previous harvesting of data, or has it been, is there something about the way that a connection has been set up, or that session IDs are being used, or anything else? So if you took the CADA, the Centre for Applied Internet Data, they're saying that 85%-ish of total internet traffic is related to HTTP and HTTPS. Modern day web architectures are complicated. That also means that the attacks are going to be complicated. So, given the amount of terabytes of data that is being exchanged in web conversations, attacks that only work, for example, on 0.01% of users are still valuable. So knowing that threat intelligence is still useful, because that might be the attack that compromises your organization. So when I say the web is complicated, it isn't just simple HTTP. It isn't just HTTPS. We have multiple stacks built for different platforms, web applications, mobile, voice, web services, all the cloud-related offerings. We have things like XML, XQuery. We have web architecture principles. They're all built on top of one web. So we have lots of different potential attack vectors. That complexity, of course, means that the diversity of attacks is high. We can have an attacker on a server, we can have an attacker on a client, you can have an attacker on a client via a server, you can have an attack on a server via a server, and of course we can have attackers on intermediaries, proxy systems. Our web applications extend into supply chains, into customer relationship systems, CRM systems, and that. So the diverse attack angles just on our main applications are also diverse as well. So the attacks can come from, so we need to learn as much information as possible, is essentially what I'm saying. So our first line of defense, if you like, for things like web applications is our good old friend, the web application firewall, the WAF. And the WAF, of course, comes in many different forms. Essentially, we're putting it as a barrier to look at which traffic is good, which traffic is bad, and block the bad. It's in its very simplistic form. It tends to act as a proxy as well. But the WAF can front our web server, it can front our load balancer. It can be used in many different ways. The WAF is our application level defense, essentially. Remember, we can put the WAF in line, out of line. I mentioned we can put it on the web server itself. It can use, again, different types of technologies. It can use both signature detection and heuristics. The important thing about having a WAF, it's often driven by PCI requirements. Remember PCI DSS, payment card industry's digital security standard. WAFs are an approved offering. They're expected as part of PCI DSS approval. Sometimes there's an argument saying, well, is the WAF going to give you everything? Can you not use it as an IDS? Well, you potentially could use it in some forms as an IDS, and that's perhaps where we're looking at the WAF more as a honeypot or probe. We'll come on to that in a second. So, particularly because we're talking about OWASP, we ought to talk about, in terms of WAFs, mod security. But mod security is the open source web application firewall, and perhaps the most popular WAF, and it's been around since about 2002 in one form or another, so a good 20 odd years. We are into version 3 now. It's designed to be an open, and of course it is supported by one of our other sister projects, the OWASP core rule set. This was first developed in 2009 as a main providing free generic rules and mod security. In other words, to be able to get people up and started with a standard set of rules for protecting your web applications without having to necessarily have the expertise to write your own to start with. So a good starting point. So what's in the OWASP core rule set? It's a set of generic plug and play WAF rules. You can choose your mode of operation. It can be standard or anomaly scoring. And it has, as you expect, a wide range of detection categories. It can look at validating protocols, identifying malicious clients, looks for things like generic attack signatures, known vulnerability signatures, things like Trojans, backdoors, looking for data leakage outbound, and things like antivirus and denial of service script use, for example. So the CRS's traditional detection mode is a bit like IDS and IPS mode with self-contained rules. Like HTTP itself, those rules are stateless. There's no intelligence shared between rules. If a rule triggers, it will execute either a disruptive or a logging action. And that type of usage is easier for a new user to understand. It's not optimal from a rules management perspective. How do you handle false positives or exceptions? And again, it's not optimal from a security perspective. Not every site has the same risk tolerance, and lower security alerts, for example, can often largely be ignored. We're interested from a sort of Honeypot perspective from the event logging capability. You can log using mod security event data to both an Apache error log and to a ModSec audit log. And that can be pushed out using the mlogc routine, either as HTTP or JSON. And you can also do a correlated mode. Those basic rules are considered reference events and don't necessarily go into the Apache error log. And those loggings analyze both inbound and outbound events and generate special events. And you can set it up in the individual configuration files within mod security to do that. Now, what's the OWASP Honeypot project about? What we really want to be able to do is take real-time, detailed web application attacks, report on them, and generate threat reports to the wider community. So this is an open community approach to making that threat intelligence data available to anyone who wants to use it. So essentially, this is a rebooted project. It's a relaunched version of the earlier of the web Spider Labs Trustwave project. And we're moving away from the dedicated mlogc based consoles, because any type of reporting tool that relies on just one logging client or logging server, an application, is dependent on that client, on that logging being able to be maintained. If the open source build isn't maintained, or several of those aren't maintained, then they'll be running into the project that you can log something, but it isn't being collected properly. So that's where that's the basis of where we've come on from. So the original project was to have essentially VM mod security based honeypots attached to dummy Apache web servers on virtual machines hosted in data centers, and they all pointed back to a mod security console host where a dedicated mlogc based application would pull the probe data together and be able to do correlations and those sort of things of the threat intelligence all together. The problem is that you might want to have multiple platforms. A virtual machine is deployable in cloud environments, it's deployable in data centers, but it's not the only platform you might want to use. Using a mlogc based almost proprietary, it's still a documented standard, but the development of a dedicated console perhaps problems. You really want to be able to feed it into some more generic tool to make the threat intelligence data more useful and to last. The problem we have when we inherited the project was that the build for the probe was there, but the consoles weren't. So we've had to sort of re-engineer what we wanted to do. So as I said before, the older event consoles were broken open source product. There was no current development. It meant started again. The deploying the virtual machine as an OVA. Yes, it's easy deployment in cloud and data center environments, but you want to think about more modern methods of deployment, containerization, Docker, for example. And we need to think about putting the threat intelligence into some sort of system that can be shared. Something like MISP as a possible example. So our proof of concept layout was a number of web clients being able to attack a dummy web application, Apache web server that sits there with mod security behind it and the CRS rules. That ModSec audit logs are pushed into ELK, essentially as JSON, using ELK, a combination of logstash and Kibana, to format it and push it as honeypot information and push it as threat intelligent into MISP. And the idea was that we can deploy some of this as Docker containers so the build becomes that more easily and multiple deployable. So one of the bits of work we've done is building honey traps and reporting threat intelligence. So being able to trap an attacker, even an automated attacker, doing certain things, and be able to, if you like, lure them with a certain amount of bait, identify the attacker from his or her actions and gather information, so from the logs effectively. So what we plan to do with honey traps is adding fake listening ports. And if an attacker is trying to access them, then there might be a presumption they could be malicious. Adding fake entries in robot.txt, and if anyone accesses that restricted location, again, it raises suspicions. Adding fake HTML comments, and if someone reacts to those fake HTML comments, again, you could tag as potentially being malicious. If we add fake hidden form fields, triggers on them means someone's looking into the HTML and trying to action things. And adding fake cookie data, and if the cookies are manipulated, again, it could be conferred as malicious. So, like if we're doing adding fake listening ports, we can generate an alert on traffic received on a fake port. We can log that with the associated client that's made the request, its IP address, etc., etc. We can identify credentials that have been used and accessing the robot.txt file. Has someone try and attack on a location that you wouldn't normally associate with being accessed? Again, are we seeing people manipulating fake HTML comments? And we can then generate a honey trap alert that looks at that. Again, hidden form fields. We can see some of the attacks that come in and access some of those types of manipulation. And again, fake cookie data is there as well. And if people are accessing those sort of files, so those sort of cookies, what are they doing with them? Why should they be accessing them in that way? So each of those types of alerts, as well as the standard other sort of things that come in via CRS, can be directed via logstash and Kibana using Elasticsearch's ELK capability and pushed into MISP. And MISP is ideal because it's there as a threat intelligence sharing platform. And that's the way in which we can make threat intelligence available. And part of the work we want to do is maybe adapt that into other formats like sticks, etc., for sharing threat intelligence a bit wider. So some of the other ongoing and future work that we're looking at doing. So we've done some of the setup proof of concept to understand how mod post security interacts with a receiving console. So we've done the VMs, we've got the Docker to store logs from multiple probes. That works. We can do multiple Docker deployments. We want to look at console options to visualize that threat data. We looked at things like the mod security audit console, Waffle. All of them had scripts for single-use probes and multiple probes, but they're broken in terms of open source deployments. So we're looking at the ELK type approach to pull that information together, and we have a proof of concept that does that. We developed a mechanism to convert the original stored data from MySQL into JSON, and also to provide a mechanism to convert the mod security audit log into a new format. And using Elasticsearch, Logstash, and Kibana, we can visualize the data. MISP now provides a way of visualizing and sharing it in a better way. So what we want to be able to do is provide a further mechanism to forward output into a threat intelligence system, essentially using sticks format, into something like the MISP project. So we can share that threat data from multiple probes and honeypots, maybe even taxi format, but we need to do in a format that MISP can deal with. We're also looking at new approaches for log transfers. JSON is what we're experimenting with at the moment, and as well as improving the honeypot to start using more of the CRS version 3 and 3.x features. Other work with is developing a new alternative small front honeypot probe, maybe based on small hardware devices. We've got a Docker version. Big piece of work we need to do is maybe a machine learning approach to be able to look at the threat intelligence and maybe ultimately be able to rewrite some of the rules. So there's an adaptive feedback routine, so we can actually challenge and change what the probes are detecting. So if there are 4 main stages of work that we want to do. First one is, if you like, some form of data massage. So we want to put the output into a threat intelligent format. Sticks and taxi would seem the most obvious. We need to develop a probe management platform whereby we can manage multiple deployments. We've already tested that we can deploy multiple Docker and VM instances and getting it all reporting back to the same Kibana and Logstash ELK platform, but we need to be able to manage those individual probes, whether it's to update CRS or to perform other sort of housekeeping operations. Also, the format of the probe, already mentioned, new alternative small footprint, honeypot and probe formats. And also, we want to be able to do those machine learning enabled rules, be able to have that feedback mechanism from the community threat intelligence that can be fed back to enhance the rules. So this might be a machine learning enabled changes to CRS, for example. This is a bit more wide or an ambitious project. So taking those small parts, what we want to do is develop a probe management solution to manage those probes, either as VMs, Docker images, or small footprint honeypots, where we can either have a push-pull approach, use an API, or use a script to manage those probes, but multiple probes need some sort of management features. If you want sort of further information, we have a GitHub repository for the OWASP Honeypot. We have some project pages, and we also obviously have a Slack channel. I have a couple of students working on the probe management over the next few months, but any other people that wish to contribute to the GitHub repository or think they can help, yeah, please get in touch, and I'd be more than happy to hear from you. If you need my personal Twitter or my email address, and I'm open for questions. Thank you.
Okay, if there are no questions, I would like to thank Adrian and everybody else for attending the session. Of course, you can reach out to Adrian anytime at his Twitter account or the email on the screen. Have a wonderful day and enjoy other sessions as well. Thank you.
Thank you.